Now let's work with problem 3. It is a combined problem of stoichiometry and ideal gas law. How do we know this? Because you will see here that you have a different pressure and a different temperature from those that are considered standard conditions, STP, 1 atmosphere and 0 Celsius degrees. As this problem is starting with grams, first we need to do the stoichiometry part of the problem to transform the grams of hydrogen into moles of water, and then once we have the moles of water vapor, we can use the ideal gas formula to transform it into liters. So let's start with hydrogen grams. We have 55 grams of hydrogen. First, we transform them into moles of hydrogen. 2 grams of hydrogen is 1 mole of hydrogen. Then we need to transform the moles of hydrogen into moles of water vapor using the mole ratio. And here we can see that 2 moles of hydrogen are equivalent to 2 moles of water. Again, as we have done in a previous problem, you can leave the 2 and 2, or you can simplify it from here and use 1 and 1. But please do not skip this just because the ratio is the same, because this will be useful for you to be aware of the unit transformation. Okay, so now what we have is moles of water here. Here we had moles of hydrogen, now we have moles of water. And with these moles, we can then go to the formula, to the ideal gas formula. So this is very, very simple. We just divide 55 by 2. If I cancel units, it's grams of hydrogen, moles of hydrogen, moles of hydrogen. And then I have 27.5 moles of water vapor, and this will be your N in the ideal gas formula. So let's calculate now the volume in liters that you have of this substance of water. If we remember the formula, PV equals nRT, and what we need to calculate here is volume. So if we isolate volume, we will have volume equals nRT over P. Let's look at the data we have in the problem. We have a pressure of 12.4 atmospheres. We have a temperature of 85 Celsius degrees, but remember that we need Kelvin, so we add 273, and we have 358 kelvins of temperature. We will use the constant for atmospheres, that is 0.0821 atmosphere liter per mole Kelvin. And we already have the number of moles. We have N that equals 27.5 moles of H2O. So the only thing we need to do here is to replace the values in the formula. Volume will be 27.5. Okay, let me do it a little smaller. It's 27.5 moles times the constant 0.0821 atmosphere liter per mole Kelvin, and then temperature, that is 358 Kelvin. All this divided by the pressure, that is 12.4 atmospheres. So we cancel the units, moles with moles, atmospheres with atmospheres, Kelvin with Kelvin, and we have liters. So it is 27.5 times 0.0821 times 358 divided by 12.4 atmosphere, and this will give you a volume for water vapor equal to 65.18 liters. This is the answer for this part of the problem.